So I'm going to do some more examples of these problems for you guys, and you got to keep an eye on that page that has all of the identities listed out. And again, you're just trying things out and seeing what happens, and hopefully you're getting these memorized and as we go. I'm going to do a couple problems here and there for you, and let's see what we got here first. In this first section, 57 to 60, they're asking to add or subtract. We got fractions, so remember you need a common denominator, and we do not have that now. And we have to multiply by factors as well. So the common denominator on this one is going to be secant x plus 1 and secant x minus 1. And that means we have to multiply the numerators of each of these fractions by the part that was missing. So, on this one, we did not have the secant x minus 1. So then we'll have to multiply 1 times that secant x minus 1. And we did not have the secant x plus 1 in this one. So then we multiply the 1 by the secant x plus 1. So that's going to look like this. Okay, so this is really just a question of, do you remember your fraction rules so far? And we're going to combine like terms, and you should see that the secants here, they're going to cancel out or sum to 0, right? Secant of x minus secant of x is 0. Negative 1 minus 1 is negative 2. So this is a good answer. I don't know what they have in the back there as their answer, because I guess you could make this a little easier, a little more simplified by foiling out the bottom, because that would be a nice simple one. So that is probably a very good answer, and also if you foiled all this out, you get secant squared of x minus 1, and that would also be maybe a little more simplified. So we'll take a look at number 60 also. And I know all we're doing here is going to combine these. Oops. So again, we need common denominators. Right now this is over 1. So we're going to multiply that first fraction, that first term, by tangent, both top and bottom. So that would make it tangent squared over tangent. Okay, so we got the common denominator, and so then our numerator is going to look like this. And again, anytime you see any of these squareds, you should automatically be thinking of those Pythagorean identities. And there is the one that talks about, if I can write it real small over here, tangent squared so we could subtract tangent over and then that's really close to what we have over here, but you notice the signs are opposite, so then that we can just that means we can just multiply everything by 1, and so negative 1 would be the same as tangent squared minus secant squared. And so that's going to make that a pretty nice substitution there that we can do in the numerator. So that'd be -1 over tangent of x. And then 1 over tangent of x is just cotangent. So then we can get all the way down to negative cotangent of x. Okay. Now, at first glance, I was looking at this thinking, oh, maybe I can simplify that down. And I actually started working it out that way originally because, you know, I could cancel a couple things here, but it got pretty obnoxious when we were going to have to re-add it again. And so I would suggest that anytime you see a squared in there, you should start thinking of the Pythagorean identities and seeing if we can, you know, if you can use one of those to make your life a little bit easier. Okay, so for this next section, they're asking us to write the expression so that it's not in fractional form. So we're just rearranging everything here. And, you know, we only have so many options that you can deal with. And so I'm looking at this tangent and secant, and, you know, we could go about trying to combine those. You know, we could change the tangent into sine over cosine and the secant to 1 over cosine. And that might get us somewhere. But, you know, I do know that tangent and secant are related by the Pythagorean identities. And very similarly to that last problem that I did. And so then, so I'm not going to combine those right off the bat because I think there might be another way to go about this. Now, I'm not sure if it's going to work or not, but this is a nice time to introduce the idea of rationalizing. Well, I guess it's rationalizing only if you have radicals, but this idea of multiplying by a conjugate. And so that's my first guess on this, because when we multiply by the conjugate, and if you remember, conjugates are just with the opposite sign. And so if we FOIL this, make sure you FOIL and or distribute, I think we'd be able to create a Pythagorean identity, and that'll go pretty quickly. Now, again, you know, I don't know that this is going to work out, but this is kind of the whole gig. You got to try these things out. So, you know, as a side note, right, the reason we're able to just do this is because we're multiplying by a version of 1, and that doesn't change the expression at all. This being the opposite sign as this does some nice things for us, and I guess I'll write it out so that you can see why that's nice if you forget. But the numerator I'm just going to leave right now as 5 times the tangent of x minus the secant of x. And then when we FOIL on the bottom, we're going to get tangent squared minus tangent secant plus tangent secant. And that's kind of the whole point of everything, is that move right there. And then minus secant squared of x. Okay, and so the whole point of multiplying by a conjugate is so this happens. Okay, and so, right, these will end up canceling each other out. And we'll have 5 times tangent of x minus secant of x. And then it'll be over tangent squared of x minus secant squared of x. Okay, and so then for the exact reason of that last problem, right, where I wrote that out for you, tangent squared of x minus secant squared of x, Pythagorean identity, that's equivalent to -1. And so then we can say that this is 5 tangent of x minus secant of x all over -1. And then, of course, to make it look, to make it look even prettier, we can write this as just -5 tangent minus secant. So my first guess was right, like luckily, but again, that just is from experience knowing that's something that would happen. So you're going to have to play around with some of this stuff. So I'm just going to run through 64 kind of quickly here. Oops. I feel like I did that. Why would I do that? And we're going to use the same idea as the previous problem. Again, the more you guys know those identities, the easier these become. I know that if I multiply by the conjugate again, I'm going to get a Pythagorean identity in the denominator. And so I'm not going to write it all the way out this time. So we're going to have tangent squared of x times that. And then in the denominator we'll have cosecant squared of x minus 1. Cosecant squared of x minus 1 is the same as cotangent squared. And then, because we have this tangent squared over cotangent squared, we should feel pretty good about something happening if we do. We can rewrite these as sine squared over cosine squared. And cosine squared over sine squared. So when we keep change flip, I guess it's not quite as what I thought was going to happen, but right, keep change flip would give us sine to the fourth over cosine to the fourth. And then we can rewrite that as tangent to the fourth. So that's not what I thought was going to happen at first glance, but we did accomplish what we wanted to, which was to get it out of the fraction form. All right, so give these a try. Learn those identities.